Welcome back to part 2 of section 7.4. We're going to continue on with some more probability stuff. Let me take this thing off. Make too much noise. Oh, good. All right, so in section 7.4, part 2, we're going to take a look at odds. All right, so when some of the original work was done by the original mathematicians on probability, a lot of the questions that they wanted to have answers for dealt with gambling and how to gamble effectively, looking at it from a very mathematical perspective, like when you should bet, what you should bet, how you should bet. If someone wins, how much should you pay them? How much should they have to bet to win that much? That kind of stuff. And so one of the earliest ways to represent it was to use odds. Okay? So odds are a different way of representing the likelihood of an event. So they measure likelihood or probability just in a different way. We usually express them as a ratio of the number of outcomes of the event desired to the number of outcomes in the complement of the event. Okay, so for example here, the odds in favor of rolling a 3 on a fair die are 1 to 5 because there is 1 outcome that you like and 5 that you don't. Okay, so if you think about the experiment, roll a die, you have a sample space, and that sample space is 1, 2, 3, 4, 5, and 6. Now, if you want the event to occur where you roll a 5, there's one way to do it, and there are 1, 2, 3, 4, 5 ways to not do it. So the odds, let me try that again. Odds in favor are 1 to 5, meaning that there is 1 positive outcome that you want. The event in question has 1 outcome in it, and there are 5 outcomes in its complement. Okay? Now, if we flip that around, we could say the exact same thing and say that the odds against are then 5 to 1. Because odds for put the thing you want on the left and its complement on the right. Odds against put the complement on the left and the thing you want on the right. Okay? And the reason that this comes about is if, let's say that you and I were going to have a little betting game, and we wanted to make it a fair betting game, meaning fair here, meaning that you have an appropriate payoff for winning and losing, then if we were going to play this die rolling game and we were going to bet on whether or not you would roll a 5, you'd put down $1, I'd put down $5, and if you roll a 5, you take all $6 off the table and keep it, but if you roll anything other than a 5, I would take all $6 off the table and keep it. So it made it real simple to figure out how much money you have to wager to make something happen. Okay. Odds can be connected to probability because all we're talking about here is sample spaces and events. And so if you have odds and you want to turn odds into probability, and you say you have the odds in favor of an event, and you know that they're A to B, that means that there are A things in your event, and so that goes in your numerator, and that the total sample space is then going to be the A plus the B because A is your event, B is its complement, add them together, you get the sample space. If you have odds against, then what you know is not A to B, but B to A, and then the probability of the complement would just be B over A plus B. Okay? If someone gives you the probability of an event and the probability of its complement, you can turn those into odds by making a ratio of those two probabilities. What we usually do, though, is when we make that ratio, then we simplify it down so it looks something like one of these. What I mean by that is, if someone told you that the probability of an event, I'm going to keep it real simple here, was 1/3, so then the probability of its complement would be 2/3, so then the odds in favor wouldn't say 1/3 to 2/3. We'd find the least common multiple of those denominators. We multiply those out, so we multiply both of those sides of that ratio by 3, and then that would give us 1 to 2. The odds in favor would be 1 to 2. Odds against then, of course, would be 2 to 1. Okay, let's take a look at some examples down here. I'll start in this upper left-hand corner. It reads, the odds in favor of my package being delivered on time are 12 to 7. Find the probability that my package will be delivered on time. Right? So reading the odds, and since these are odds in favor, the event I want to have happen has 12 outcomes in it. Its complement has 7 outcomes in it. So the number of elements in the sample space is going to be 19. So then the probability of A, or if we want to write it out with the words from the problem rather than using that A, come on, erase. Oh, there we go. The probability of on time would then be the 12 ways to be on time out of the 19 ways in the sample space. Right? All right. This next one we're going to do over here in the upper right. This one's a little trickier. I just wanted you to know that it's written purposefully to be somewhat deceiving. Right? It reads, the odds against winning a casino game are 5 to 4. That means that our B is 5 and our A is 4 because it's written as odds against, not odds for. But they want us to find not the probability of losing, but they want us to find the probability of winning. Well, the probability of winning, when you're converting odds to probability, is always A over A plus B. So that's going to be 4 over 4 plus 5, or 4 nights is going to be our probability. That's a 4 nights. Do you see how it was kind of tricky? Because they gave us the odds in the negation or in the complement sense, but asked us to find the probability directly. Okay. All right, down here in the lower right or lower left, probability of student will show up on time. So the probability of on time is 0.32. What are the odds that will show up on time? Well, the probability of on, whoa, I wrote that wrong. Probability of on time is equal to 0.32. So the probability of not on time would then be 0.68. So then the odds are going to be 0.32 to 0.68. But that's ugly. I can't leave it like that with decimals over there. So I'm going to multiply both sides by 100. And why did I choose to multiply both sides by 100? It's going to clear out my decimals. And that's going to give me 32 to 68. But I can reduce that. I can at least divide by 2. That will give me 16 34s. But I could go even further and I could say that that's 8/17. And so this would be the correct answer. Right? So I'm using the formula that was given to me. It says to turn probability into odds, put the probability of the event on the left, and put the complement on the right, and then I'm going to make those into whole numbers. So do whatever it is I got to do. Since these were both decimals to 3 decimal places, I multiplied by 100 and then simplify. If they had been to 2 decimal places, I would just multiply by 10. If they had been fractions, I'd multiply by the common denominator. It's all of those sorts of things. Okay? All right, last example, and then we're done with section 7.4. The probability that an event won't happen is 0.56. So the probability of the complement is 0.56. That means that the probability of the event is 0.44. And they want us to find the odds in favor of it occurring. Odds in favor is the probability of the event colon the probability of the complement. So that's going to be 0.44 to 0.56. But I'm going to do the same thing I did last time times 100 will give me 44 to 56. And then I'll reduce that. 22 to 28, 11 to 14. All right. Now remember, what is this supposed to be telling me? Well, It's telling me that there are 11 ways to win and 14 ways to lose. So if we were going to bet on this game, I'd throw down $11 saying it's going to happen. You'd throw down $14 saying it isn't going to happen. If it happens, I win, take it all. If you win, that means that it didn't happen and you would take it all. All right. Well, that was easy enough. That was section 7.4. I'll see y'all back here in the next set of videos for section 7.5.